So yesterday we were talking, we had a blended learning type of day where we had 2 videos to watch. If you were not here, please watch those videos as soon as possible, okay? Because that will help you in doing today's work, tomorrow's work, yesterday's work, the rest of the class's work, and so on and so forth. Okay? Okay? So today we've got 6, I think there's 6, yes, there are 6 on this slide. I only have 2 of them presented here for you right now. We have 6 on this slide. I'm going to do the first 2 together with you. You're going to do the next 4 by yourself, okay? And we're going to talk about these things. I draw your attention to the fact that reference angles, remember, always come off of the horizontal axes. Reference angles always come off the horizontal axes. And it's a way to get the angle into an acute angle, because then everything's positive. Right? That's the nice thing about reference angles, is that everything's positive if it's an acute angle. Okay? When you get into quadrant 2, then only the sine is positive in quadrant 2. In quadrant 3, only the tangent is positive. In quadrant 4, only the cosine is positive. Okay? Everything else is negative. Okay? So, how I would go about this is I would first draw myself a little picture. Okay? So, negative 150 degrees is going to be somewhere down here. That right there is my negative 150 degrees. Which leaves me with, then, my reference angle, theta prime, being up in here. Up in here. Okay? Comes off of the horizontal. So the first question, find theta prime. Well, theta prime is going to be, I should put what theta prime actually is. Theta prime is going to be 30 degrees. Okay? Then I want a positive and a negative coterminal angle to go along with it. So on this one, a positive coterminal angle would be 210 degrees. A negative coterminal angle would be negative 510 degrees. From yesterday's video, does anybody know how it's very easy to find a positive and negative coterminal angle? Emily S., I saw your hand first. So we add 360. Or if we're going in the negative, we would subtract 360. Okay? That's the way. And would it matter if I went 2 laps around? Because those would also be coterminal angles there too. So I could add or subtract 720. Add or subtract 1080. And that would be 3 laps around. Okay? So we got that going for us, which is nice. Okay? Number 2, or really it's number 5, but I'm going to call it number 2. Okay? So a 70-degree angle is up here. Which, because it's in quadrant number 1, it's its own reference angle. So my reference angle here is 70 degrees. Quadrant 1 is its own reference angle. Okay? A positive coterminal angle here would be, if I add 360 degrees, I'm going to go with 430 degrees. A negative coterminal angle there would be negative 290 degrees. With me? Questions on any of those? All right, you try them now on your own. See, I'm not a big fan of this grayness. There we go. Make it the gold. Matches my shirt. Okay. So, you, and those of you playing along at home, find me the reference angle and a positive and negative coterminal angle. All right, so negative 250 degrees puts me actually all the way into quadrant number 2. Okay. Which puts my reference angle right there. So that would be 90 to get to there, 180 to get to there. So that's a reference angle of 70 degrees. Agree with that? Okay. Adding 360 degrees to that gets me 110 degrees. Subtracting 360 degrees from that gets me negative 610 degrees. Do we agree with that? Okay. Negative 35 degrees for my theta puts me down here. That also then becomes my reference angle except positive, okay, because it comes off the horizontal. So my reference angle then is positive 35 degrees.
Our reference angle is always positive?
Always positive. Because that puts them in quadrant number 1. Adding 360 degrees to that gets me 325 degrees as a coterminal angle. Subtracting 360 degrees gets me negative 395 degrees as a negative coterminal angle. Yes, ma'am?
Can you go back to number 6 and explain theta prime? How you get 70?
This part in here, agree with me where it's located.
Yes.
Okay? So then this part in here, oops, tap the brakes. This part in here then is 90 degrees, right?
Yep.
This part in here is 90 degrees, right? Which leaves me with 70 degrees to go to get to negative 250 degrees, right? 90 plus 90 plus 70 is 250. Okay? So that 70 then is my reference angle because reference angles always come off the horizontal. Okay? Switching gears now, let's switch into radians. Done exactly the same way. Okay? So first off, where is 2 pi over 3? Well, that's up here. Which puts my reference angle down here. Right? Okay? So my reference angle is pi over 3. Because now instead of trying to get to 180 degrees, I need to get to pi radians. Yes, ma'am? Pi over 3. Yeah. Because it's in, if the problem's in radians, keep it in radians. If it's in degrees, keep it in degrees. Okay? Now, in number 2, instead of adding 360 degrees, what am I going to add? 2 pi. Or in this case, really I'm going to add 6 pi over 3, because that's equivalent to 2 pi. So this would be 8 pi over 3, or subtracting 6 pi over 3, negative 4 pi over 3. Okay? Seven pi over 4 is down here. So there is my theta, which leaves me with theta prime, or my reference angle, right there. So that I need to get to 2 pi now because I'm in quadrant number 4. So my reference angle is going to be pi over 4. A positive angle in the same location. Now I'd be adding 2 pi, which I really am thinking 8 pi over 4. So that would be 15 pi over 4, or negative pi over 4. Okay? Questions on any of those? Yes, ma'am.
I'm so confused on that one. I thought to find the reference angle, you just went to the next, like, 90-degree angle point.
No. Always comes off of the horizontal.
So you're just trying to go to the x-axis.
You go to the x-axis. Off of the x-axis. You can't. Did you give me 20 there as a? Yeah, that one. You don't go off the vertical. Always go off the horizontal. Okay. So now let's switch it up a little bit. Let's switch gears just a little bit. Okay. So let's say that theta is in standard position, which means that the initial point of the ray is at the origin, okay? With a terminal side of theta through the point x comma y, we want you to find the sine, the cosine, the tangent, and what the actual angle is, okay? So first off, I would start with drawing yourself a little picture again. Where is negative 5 comma 12? Which quadrant? It's in quadrant number 2. Okay? So my theta is going to go through negative 5 comma 12, which is down up there. So here is my actual theta. Which means then, to make everything nice and positive, my reference angle is there. With me on that, E?
Yep.
Okay. Okay. So now, if I break out that triangle, here is my theta prime. Here is, this side over here is 12. This side over here has a length of 5, because I went 5 left and 12 up. What's my hypotenuse then? $12 squared is 144. 5 squared is 25. 144 plus 25 is 169. Square root of 169 is 13. Okay? Pythagorean triple, 5, 12, 13. Okay? So, based off of my reference angle, theta prime, what is the sine, the cosine, the tangent of my reference angle? sine of my reference angle is, looking at this triangle, opposite over hypotenuse, 12/13. Right? Cosine of my reference angle is going to be adjacent over hypotenuse. Agree? Tangent of my reference angle is going to be opposite over adjacent. Agree? Yes? Okay. Now I can use any one of those three to find what my reference angle is, correct? Okay. So I could use theta prime here is the inverse. I'll use sine just because it's the first one. But if you're a fan of cosine, you could have done inverse cosine there. If you're a fan of tangent, you could have done inverse tangent there. And then you go to a calculator and you go inverse sine of 12 divided by 13, and you get that. But what's that in? That's in radians. So you convert that into degrees, right? Okay, so there's that. Okay, so that tells me then that theta prime, my reference angle here, is 67.380 degrees, or 1.176 radians. Yes, ma'am.
So, on the test you had us do it to tenths. Is it okay to do it?
That's fine. I do more just because I have to do more because I've got to teach you how to do less. You know what I mean?
Yeah.
Okay? All right? So there's all my stuff, right? Okay? But now which quadrant is theta actually in? Which quadrant is theta actually in? It's in the second quadrant, right? Okay? What can you tell me about the angles in quadrant number 2? They're what? Okay. They're more than 90. Less than 180, which would be more than pi over 2. Less than pi, if we're in radians, right? Which is, if you did pi over 2 and on a calculator and rounded it, it's 1.57. Okay? Pi is 3.14. Okay? What else? The cosine's negative in quadrant number 2. Did you have one? What else? Sine is positive. What else? Tangent's negative. And then likewise the other three, so if cosine is negative, that means secant's negative. If sine is positive, that means cosecant is positive. If tangent is negative, that means cotangent is negative. Right? Okay? So when I go now, when I switch this over to the sine now of my actual theta, it's got to be positive, correct? Right? So that's going to stay 12/13. Same as in my reference angle with my reference triangle. However, the cosine of theta has to be what? Negative, so it's going to be negative 5/13. The tangent of theta has to be what? Negative, so it's going to be negative 12/5. Right? Now we just got to find theta. Okay? So a little side note action here. Theta in quadrant number 2 is 180 degrees minus my reference angle. Right? Or pi minus my reference angle. Correct? In quadrant 3, theta is 180 degrees plus my reference angle, or pi plus my reference angle. In quadrant 4, it's 360 degrees minus my reference angle, or 2 pi minus my reference angle. Okay? So, knowing that now, theta here is going to be 180 degrees minus 67.38 degrees. So theta is going to be 112.62 degrees. Or if you're Nina, it's 0.6. Okay? In terms of radians, theta is going to be pi, so 3.14, minus 1.176, or 1.966 radians. Okay. Does anybody see, let's see if I can get them on there. There, I can try and get them on there. Does anybody see a pattern yet? Probably not, because it's the first one that we've done. Okay, so let's try another one. Let's try this one. Theta now goes through the point negative 3, comma, negative 4. You find me, again, I want the sine, the cosine, and the tangent of theta, and I want theta. Okay? So you find me those 4 things based off of this scenario. Alright, so negative 3, negative 4, negative 3 comma negative 4 is down here. So theta comes all the way around here, which puts my theta prime right in there. Okay. Break out that triangle. Theta prime is here. This is 3. This is 4, which makes this hypotenuse be how much? 5. 3, 4, 5, right triangle. Yep. Okay. So the sine of my reference angle then would be 4/5. The cosine of my reference angle would be 3/5. And the tangent of my reference angle would be 4/3. Agree with all of those. Okay. Using one of those, we would then find theta prime. Okay. I'll say, again, I'll just use sine just because it's the first one listed. That gives me a reference angle here in degrees of 53.130 degrees, or that is 0.927 radians. Agree? Okay.
I have a question.
I have an answer.
So in these instances when it's not given either radians or degrees, do you want both of them, or should we just pick which?
Pick one. Yep. On the, we'll tell you what we want it in.
Okay.
Okay. All right. We are in quadrant 3. right? So in quadrant 3, what's positive? Tangent's the only thing that's positive. Okay? So that means then the sine of theta then would be negative 4/5. The cosine of theta would be negative 3/5. Add 5. The tangent of theta would be 4/3, because that's the one that you said was positive in quadrant number 3. Agree with that? Okay. Theta is going to be here, because we are in quadrant 3, theta is going to be 180 degrees plus my reference angle. So that's going to be 233.13 degrees. Or it's going to be pi plus my reference angle, which is going to be 4.069 radians, depending upon which you have. Agree? Okay. Did you see now if I can get it? Nope, I guess I can't. Did you see a pattern yet? You got one? What do you got?
It's kind of you just use the reference angle and then either subtract or add 180 to find your.
Okay. Okay. Anybody see another pattern? All right, let's try one more.
Wait, are you talking about patterns within the problem?
Yep.
Or like comparing the two problems?
There's a pattern that you can find in the problem. And you will be able to fill all of this in. Promise. Okay? Try this one. That's a bad 15. For some reason, Promethean does not like my 5s. I gotta get slower with them. Yeah, I get it. It's not drawn to scale. See, it doesn't like my 5s. Agree? So that tells me that my reference angle, which is right there, my reference angle is 61.928 degrees, or 1.081 radians. Agree? Okay. So, I'm in which quadrant? I'm in quadrant 4. Oops, that's theta. Is in quadrant 4. So what's positive in quadrant 4? Cosine. So my sine negative 15 over 17. My cosine will stay 8/17. My tangent becomes negative 15/8. So see, it doesn't like it again. My tangent becomes negative 15/8. And my theta is going to be 360 minus my reference angle, which is 298.07 degrees, or 2 pi minus my reference angle, 5.202 radians. Yes, ma'am?
When you're looking, if you could, can you scroll up?
Mm-hmm.
When you're looking at your triangle where theta prime is it always the angle to the center of the circle?
Mm-hmm. Because it always comes off the horizontal. Mm-hmm. If you always draw your triangle in reference to the quadrant that it's in.
Okay.
You know what I mean?
Yep.
Okay. Anybody see a pattern yet? No? Alright. Look for the pattern tonight. We'll start tomorrow by giving you what the pattern is. Okay? Have a great day.